Alright, so I wanted to run through a couple of just ideas with probability, talking about with playing cards. And just to kind of reiterate a couple pieces with how all these different pieces interact with each other. So what I've done is I've designated X as being a random variable, which means this is essentially what we're observing, what is the behavior that we're interested in knowing more about. And X is the number of aces drawn from a deck of cards when drawing 2 cards. So right here, this statement right here is P is equal to P of X equal to 0 is asking about no aces. So what is the probability of doing that? So the easiest thing to do is just think about the fact that we have 4 aces in the deck. We want to draw 2 cards at a time, but we don't want any of these to be the cards we draw to be any of these 4 cards. So we have these 4 that we can pull from. So there are, if we include the entire deck here, there's 52 cards possible in that deck. So that's the total number of outcomes, right? When we're pulling a card out, we have 4 options for pulling an ace, and we have 48 options for not pulling an ace, because that's what we're interested in here. When X equals 0, it means that this random variable is 0. X is the number of aces that we're going to draw at a time. So here we're saying pull no aces. So this is 48 out of 52 ways to pull no aces. So what we've done at that point is that we still have the 4 aces in the deck, but we've removed 1 card from the deck. So this card that we played out is no longer a part of that deck. It's already been pulled away. So now there are the 4 aces, and still there is the rest of the deck, which means that we now have 51 cards left in there, right? And then we have 47 that are not aces, okay? So then we just do that figuring, but this is X equals 0, the probability of X equal to 0. And normally we write that as a capital X, so I'll just re-emphasize that a little bit better by writing it bigger, okay? Just like we normally write this as a capital X. And that's what this is supposed to look like, right? And then at this point, we grab our calculator, and we just do that figuring. So, I'm going to do 48 times 47. And I'm going to do 52 times 51. And then I'm going to do that division. And that is the probability of not pulling any aces out of the deck when pulling 2 cards. Now some of you may also be wondering, why are we multiplying these? Because the idea here is that we're essentially looking at a combination. So there's 48 ways and then there's 47 ways of making it happen. So how many combinations are there to make that occur? 48 times 47. That's how many different ways we can pull 2 cards out. And then we have 52 and then 51 because there are 52 ways we can pull any card, and then 51 ways we can pull any card. So we're dealing with actually I guess it's a permutation is what we're doing with on these 2 pieces here. So we multiply straight across, we get our overall value there, and then we multiply that out. So essentially what we're talking about here is 85.0%, or just 0.8506. Of course, pay attention and make sure you're addressing how many decimal places we're wanting. And that's normally the piece that we're talking about there. Okay? Thank you.